On EIGRP operation, let's say that you enable your interface, it's up, and it has an IP, which are basically the two requirements for an interface to show in the routing table as directly connected, obviously. So it has to be up and it needs to have an IP. Then you can configure the routing protocol, in this case EIGRP. You enable EIGRP, and the first thing that the router will do is send out hello protocol, hello packets, and they are sent to 224.0.0.10, destination IP 224.0.0.10, or in the case of IPv6, you saw it's FF02::A. So that means that every EIGRP router will receive that hello, will be able to read that hello. And for the routers to become neighbors, to successful see each other as neighbors, the routers must have the same autonomous system number. So whenever you enter router EIGRP 100, doesn't have to be 100, could be any number, but it has to be the same number on all routers for those routers to become neighbors, to create a routing adjacency, to recognize each other as a neighbor. So the other element that needs to match is the routers need to have a common subnet. Common subnet, meaning that if they're in a point-to-point link, they will be in the same subnet. And if they are in a broadcast multi-point, multi-access, then they should be in the same subnet. Also, I would add, if there's authentication, then that has to pass on all routers. So authentication needs to be successful on all routers. Then a hello is sent back, hellos are exchanged, the routers recognize each other as neighbors, and then they show on each other's neighbors table. From there, the routers will then start exchanging updates. That's information about the directly connected networks that you instructed the router, that you have configured the router to advertise. So interface has to be up, needs to have an IP. The routers need to become routing protocol neighbors, EIGRP neighbors. You can see that with show IP EIGRP neighbor. Show IP EIGRP neighbor, see it as a neighbor. At that moment, the routers will then start exchanging information on how to get to the direct, start advertising the networks that you have instructed the protocol to advertise. And with those updates, you see that all updates are acknowledged, reliable transport. With all those updates being received, the topology table is built. So the topology table contains the information on every possible destination and every possible way to get there. So that information is stored in the topology table, topology database. So when all updates about all possible destination, all networks have been learned, are present in the topology table, the routing protocol then runs the algorithm, in this case dual, in the case of OSPF, it's Dijkstra. So the dual algorithm then runs or analyzes all the information in the topology database, and then the best, according to the metric, you see that a little later, according to the metric, the best metric is then the path with the best metric is then placed as the successor or the best then is then installed in the routing table. And that's a basic overview of how the three tables, very importantly, neighbors first, topology. From the neighbors, the topology is learned, and then the routing table is derived from that topology table.